All right, hey kids. As we take a look at problem number 13, I've kind of set up some things to get this started a little bit quicker. What we have is we have a system where we have the object pivoting right here. So this is our center point, or our pivot point more particular. The problem is asking for how much force do we need to apply straight up here in order to counteract the torques that are actually pulling this thing down. And that there's four torques in this problem. We have the torque from the meter stick, the torque from the first mass, the torque from the second mass, and the torque from the third mass. So I've written these over here, and also what the equation is for the torque of the meter stick. Now I could go and find the force of each one of these objects, but I'm just gonna wait on that for a little bit. So I'm consistently writing this as lever arm times mass. Now I can do lever arm times force, but I hope that you guys are going to stay with me here. And I could keep it as grams. I could turn it into kilograms. It's really up to you. I just know I'm going to try to be consistent with my approach here. So in this first one, I know that the lever arm, which is the where the mass of the meter stick is located at, we're assuming is right in the center. So that's right at half a meter, and that is literally half a meter away from the end. So the lever arm is 0.5. Now, its mass, I could write that a couple different ways. I can write it as 138 grams. I could write it as 0.138 kilograms. I could convert it into force if I wanted to as well. I'm just going to stick with 138. It really doesn't matter at this point in time, just based on how this problem's set up. But as we do 0.5 of 138, I get about 69. And what that ends up being, if you will, is it's going to end up being a meter times a kilogram. That's really what it is. So it's like a gram meter is what that ends up being, which is kind of a weird unit, but we're just going to kind of hold out there for a little bit. So as we look at torque 1, which is this one, it says it's at the 82 centimeter mark, which means that it's 18 centimeters from the right edge. So I'm going to convert that into meters. That's what I did over here. So 0.18 is that value. Yep. And then I'm going to multiply that by the gram, which is 150. So when I do that, when I take 0.18 times 150, I get 27. And that's grams meter again, which is a weird sounding unit. Then we have torque 2, which is this one right here. And that has a mass of 550. And it's 45 centimeters mark, all right? And we're assuming that's from the left edge. That means it's 0.55 meters from the right. So I'm going to write 0.55 times 550. So 0.55 times 550, and we get 302.5 gram meter. Very weird unit. And then we'll do torque 3. Torque 3 is 250 grams that's suspended at the 35 centimeter mark, which means it's 65 centimeters away, or 0.65 meters away, and that is 250. So 250 times 0.65, and I get 162.5 gram meters. All right, so what I'm going to do is I'm going to add all of these torques up. So I'm going to take 69 plus 27 plus 302.5 plus 162.5. And that's going to give me a total torque of if I did my math right, 561 gram meters. Now, that's awesome. At this point in time, I probably want to convert my 561 gram meters to something else. If I wanted to convert from grams to newtons, what I would do is I would take that 561 and I would divide it by 1,000, which would give me 0.561 kilogram meters. And then if I wanted to turn that into a force, I'd multiply that by 9.8. So I take 561 divided by 1,000, which is 0.561, and I would multiply that by 9.8. And what I get as a result from all of this is about 5.5 Newton meters. That's my overall torque that I have in this system. So if I want to figure out how much force needs to be applied from this object to counteract it, what I need to look at is, okay, is another torque problem. Okay, in this case, this is the amount of torque that I have to basically be able to apply. So it's my total torque, and I want to know force, and I'm going to multiply it by its lever arm. Well, I know the total torque that I'm trying to figure out, which happens to be that 5.5. I do not know the force I need to apply. The lever arm from here all the way to here happens to be 1. So, as I look at this problem, it ends up being fairly easy. I just take 5.5 divided by 1. So the force required is literally 5.5 newtons. All right, that's 13.